Hello students, welcome to Academy, the place for mathematics and science. Dear students, in today's class, we are going to continue the chapter Gravitation. And remember, this is third period of this chapter. In the second period, we solved some important numerical problems on gravitational force, right? Even we also focused on the laws of planetary motion given by Johannes Kepler. Now, let's go for continuing today's class by recalling these points one by one. And before going to that, let me show you yesterday's question paper as well as last week's question paper. Dear students, this is the question paper and the test was conducted on the chapter Gravitation and it was conducted for 15 marks. These are the questions. This is first page and is of second page. Take both the pages screenshot and you can use them for practicing. This is of last week's question paper and the test was conducted on the chapter Triangles and it was conducted for 25 marks. These are the questions in first page and it is of second page questions. This is third page. And these are the questions in fourth page. Again, take the screenshot of all of these and use them for practicing. Yes, students, now let's continue the chapter Gravitation. In the last class, we solved the problems on gravitational force, right? Could you recall the formula used to find out gravitational force? Yes, you are right. It is F is equal to G into M1 M2 by d square. Here F is called gravitational force. What do you say about G? G is the gravitational constant. Then what is its value? This is 6.67 into 10 raised to the power minus 11 Newton meter square kg to the power minus 2. Then what is the unit of gravitational constant? This is only Newton meter square kg to the power minus 2. Who discovered the value of gravitational constant? Yes, he is Henry Cavendish. Next, where M1 and M2 are the masses of two bodies, right? And D is the distance between the centers of two bodies. Then after that, we learned the important laws of planetary motion which were given by Johannes Kepler, right? Then which is the first law? Very good. It is called law of orbit. Then what is its statement? It is every planet revolves around the sun in an elliptical orbit with sun is situated at one of the two foci. Right? Next, what do you call the second law of planetary motion? It is called law of area. Then according to this, the imaginary line joining sun and the planet sweeps equal areas in equal intervals of time. Got it? Next, what about third law? It is law of period. Then what is its statement? This is the cube of average distance between the sun and the planet is directly proportional to the square of the total period of revolution of the planet, and this is the only law which can be expressed mathematically. Can you tell how can it be expressed? It is r cube is directly proportional to t square. This can also be written as r cube by t square is equal to constant. Even this can also be written as t square by r cube is equal to constant. Followed? Okay, now let's go for continuing today's concept. Dear students, here I have drawn some of the diagrams. Just observe them. And all these diagrams are related to the concept which I am going to explain it now. Observe these figures one by one. This is first one. Here is a ball. It is hit by a batsman. Then obviously the ball goes into the air. when it goes into the air, will it fall back to the ground? Yes, certainly. Why it is so? It is due to the gravitational force of the earth. Then here, can we say that the ball is falling towards the ground is under the influence of gravitational force of the earth? Yes. Now, observe the second figure. Here, we know that the skydiver, they fall from the great height. When they are falling, they move towards the ground. Here also, the gravitational force will be acting. Then can we say that whatever the motion experienced by the skydiver is under the influence of only the gravitational force of the earth? Yes, this is also. Next, observe this third figure. In this, imagine a situation that the plane is not under the control of pilot. That means it is falling towards the ground freely, right? So here also the motion of this plane is under the influence of gravitational force. Come across the fourth one. It is the water slide game. In this, assume that, just observe here, the person is moving on the track of this water slide, and when he is moving, sometimes he feels that he is not exactly on the surface of this track, right? In this condition also, the person will experience, or the motion of the person will be only under the influence of gravitational force. There will be no other support at all. And observe this fifth figure. You are very familiar with this. So, could you tell which game is that? Is this? It is Columbus. Assume that here the person is sitting at one of the end of the Columbus. When it is swinging and when it goes to the extreme, then the person will not sit exactly on the Columbus. He will be just above that one, right? The reason is here also the person will, the motion of the person will be only under the influence of gravitational force. See, in all these five figures, we can come to know that the motion of the object is under the influence of gravitational force only. No other support is there. There are some objects are falling and some objects are experiencing the motion under the influence of gravitational force, and we call this as free fall. This experience is known as free fall or free fall object. Clear? Once I tell the definition of free fall, it is when the object is falling towards the ground is under the influence of gravitational force only, then it is called free fall. Got it? Yes. Now let me go for writing the definition of free fall. Dear students, here I have written the definition of free fall. See that? The motion of a body under the influence of gravitational force of the earth only, then it is called free fall. Got it? If the body is falling towards the ground only under the influence of gravitational force of the earth, that is called free fall body. With respect to that, just I'll ask you two simple questions. Try to answer them. When the body is falling freely towards the ground, whether its velocity changes or not? Definitely it changes. Now another question. If the velocity is changing, whether it increases or decreases? Very good. The velocity increases, because when the object is falling freely towards the ground, as it approaches the ground, the gravitational force will be more. Due to that, it moves faster towards the ground. As a result of it, velocity increases. Clear? The first point is, when the body is falling freely towards the ground, the velocity changes. And second one, when it is falling freely towards the ground, the velocity also increases. And one more question. When the object is falling freely towards the ground, whether it changes its direction or not? Yes, there will be no change in the direction. See, you can observe that. Here the ball is falling, it is in the same direction only. Here also, when the object is falling freely towards the ground, there will be no change in the direction. Please do remember these 3 points. One is, when the body is falling freely towards the ground, so the velocity changes. Second point, velocity increases. Third one, there will be no change in the direction. Clear? Okay, dear students, here I am going to take 2 objects. Observe, what is this object? It is just a piece of paper, and here is a marker. I am going to leave these 2 objects simultaneously from the same height, and you should think, you just observe this and think and answer whether these 2 objects will fall towards the ground simultaneously, or one after the other, or if one after the other, which one will fall first. So that is, which one will reach the ground first. You have to tell that one. Just observe these 2 carefully. Yes. What do you say? Yeah, you are all thinking that the marker pen will fall to the ground first, right? Now, why it is so? And you all may be thinking that, sir, marker pen, it is heavier than paper, or the paper is lighter than marker pen. Okay, now here I am going to take these 2 objects, these 2 papers. Look at these 2 pieces of paper of same size, but one of this is going to be crumpled. Now again I am going to leave these two from the same height. Now you should tell whether these 2 fall to the ground or touches the ground simultaneously or not. Yes, what do you say? So you may tell that the crumpled paper will fall to the ground first. Once you observe this, it is, look here, I am going to leave these 2 simultaneously from the same height. Yes, what do you say? Again, you can say that the crumpled paper reaches the ground first. Here, what may be the reason? Do you say that crumpled paper is heavier than the ordinary paper what we have taken? No, both are having the same size and their mass is same. Then what is actual reason for this? See that here, whatever earlier you said, in case of marker pen, it is heavier than the paper, that's why it touches the ground first. The same concept was given by a scientist, that is Aristotle. But this misconception was removed by another great scientist, is Galileo Galilei. Then we have to give reason for this. Means according to Galileo Galilei, irrespective of the mass, size and nature of the object, when they are dropped from the same height, both will reach the ground simultaneously. Both will reach the ground simultaneously. Followed. But in case of this, why it did not happen? The reason is, see that, in case of paper, when it is falling towards the ground, see that, its larger area will experience the greater force from the air. So that is why it will reach late. Followed? Dear students, here whatever the object it may be, when it is falling freely towards the ground, there will be change in the velocity. The velocity will be increasing. If there is change in velocity in the unit time, what it is called? It is called acceleration. Followed? And this acceleration is due to the gravitational force of the earth. Therefore, it is called acceleration due to gravity. Clear? Once I tell you, the acceleration gained by a body, due to the gravitational force of the earth is called acceleration due to gravity and is denoted by the symbol small g. Okay, now I'll go for giving you more information about acceleration due to gravity. Before that, you just go for copying these 2 points. Dear students, please go through these important points that have been written in note, and you should also copy them. First one I have given: when the object is falling freely towards the ground under the influence of gravitational force of the earth, then the velocity of the body changes and the velocity of the body also increases. As it increases, there will be change in the velocity. Due to change in the velocity, obviously the body gains the acceleration. So that will be explained in the later part. And another important point, there is no change in the direction of motion. Next, second point is, heavier objects falls first to the ground on comparing with light objects. So this conclusion was given by Aristotle, but this misconception was removed by Galileo Galilei, and he tells that, Galileo Galilei tells that whatever the type of object may be, irrespective of shape, size and its nature, when they are dropped from the same height, they leave the ground or they reach the ground simultaneously, but there should not be air. Means when the objects are dropped from the same height in the vacuum, both the object will touch the ground simultaneously. So in case of paper and marker pen, we came to know that when they are dropped from the same height, marker will reach the ground first. Whereas in case of paper, it does not happen. The reason is, as the paper has larger area, it experiences the more force from the air. Clear up? Okay. Next, another point. As we know that when the body is falling freely towards the ground, there will be change in the velocity. Due to change in the velocity, the body gains the acceleration. This is due to the gravitational force of the earth and is called acceleration due to gravity. Here we have the definition. The acceleration gained by a body due to gravitational force of the earth is called acceleration due to gravity. And acceleration due to gravity is denoted by the symbol small g. It is denoted by small g. And its SI unit, System of International Unit, is meter per second square. Second square. Symbolically, it can be written like this: m bar s square, because it is nothing but acceleration. What is the SI unit of acceleration? It is meter per second square. That's why SI unit of acceleration due to gravity is also same. Dear students, now we shall go for deriving the formula to calculate acceleration due to gravity. Even we will come to know its value on the surface of the earth. Observe. First, I'll go for explaining its derivation. Assume that the body is falling freely towards the ground. So this is the object. You may call its mass as small m. And this is falling freely towards the ground. This is the ground. That means earth. You may call its mass as capital M. And the distance between the centers of these two objects, you may take this as small d. Followed? Then we know that as when the objects are having the masses, then there will be force. What do you call that force? It is called gravitational force. Could you tell the gravitational force exerted by the earth on this object? Yes, you are right. It is F is equal to G into M into capital M by D square. Earlier we used to write G M1 M2 by D square. But here we have taken mass of the object as small m, mass of the earth as capital M. Got it? Let us call it as 1. Equation 1. And dear students, in the very first chapter called motion, there we have learnt about laws of motion. In that, second law of motion, which is also known as law of momentum. Can you recall it? Yes. You are right, it is. The rate of change of momentum of a body is directly proportional to the force. Right? So that can be written as F is equal to m into A. But here small a is acceleration. This A acceleration is to be taken when the object is changing its velocity on the ground. But when the object is changing its velocity, when it is falling freely towards the ground, then we consider that as acceleration due to gravity, that is small g. So can we write this as mg? Yes, it is according to Newton's second law of motion. Once I tell you, the force exerted on an object which is falling freely towards the ground is F is equal to m into g. We may call it as equation 2. Then observe both the equations. What do you say? So these are the two things which are equal to the same thing F and are equal to one another. That is Euclid's axiom. Just mathematically I told you that directly we can write from 1 and 2. We can write it is m into g is equal to g m by d square. See that m is mass of the object, so we can cancel m and m. Now g is equal to g m by d square. So this is the formula used to find out acceleration due to gravity. Understood? Okay. And this formula can be rewritten according to the position of the object. It may be on the surface of the earth, it may be at some height from the surface of the earth. Let's go for rewriting those formula. First, you copy from there to here. Afterwards, I'll give you the derivation. Dear students, even you should write the derivation from there to here. So first, you have to draw the figure on the right side, this one. Then after that, on the left side, you should write m is the mass of the object and capital M is the mass of the earth. And d is the distance between the centers of the object and the earth. Then the gravitational force acting between the object and the earth can be written as F is equal to g into m, capital M by d square. You may call this as equation 1. Then according to Newton's second law of motion, we can write the force acting on an object falling towards the ground is given by F is equal to m into g. Both are forces and they are equal to these two different things. Hence, from 1 and 2, we can write m into g is equal to g small m capital M by d square. Mass of the object on either side get cancelled. Remaining g is equal to g capital G into capital M by d square. This is the formula used to find out acceleration due to gravity. Then here small g is acceleration due to gravity. Capital G, it is the gravitational constant. M is mass of the earth and d is the distance between the centers of the object and the earth. Got it? Yes, please go for copying it. Here I'll write hence g is derived. G is derived. Copy this. Dear students, we know that the formula to calculate acceleration due to gravity can be rewritten based on where the object is, whether it is on the surface of the earth or away from the surface of the earth. Let's go for writing that formula. We know that the general formula used to find out G is acceleration due to gravity. It is capital G into m by d square, right? Now, look here. First case, when the object is on the surface of the earth. Okay, this is the earth and here is the object. Object mass is m, earth mass is capital M. When the object is on the surface of the earth, what will be the distance between the centers of these two objects, that is object and the earth? It will be equal to radius. Hence, we can write G as capital G into m by it is capital R square. Followed? Okay. Here the distance from center of the earth to the center of the object. See, from the center of the object to the ground, it is negligible. Hence we take this as radius only. Therefore we can write G as Gm by R square. And the second case, where the object is h meter away from the surface of the earth. Okay. Here is the earth, its mass is capital M. And here is the object. And this object's mass is small m, and this is at a height of h meter. Then acceleration due to gravity, it is G is equal to Gm by d square. What is the distance? Distance between the center of the object to the center of the earth, it is nothing but height of the object from the surface of the earth as well as the radius of the earth. We can write it as r plus h whole square. Followed? Okay. These two are important formulas, should be remembered. Now, dear students, acceleration due to gravity depends on some of the factors, right? We know that as the object which is falling towards the ground approaches the ground, the acceleration obviously it increases. So it depends on the height of the object from the ground. Not only this, it depends on some other factors. Now we will come to know that factors on which G depends. Before that, you copy from there to here. Dear students, now let us come to know the factors on which G depends one by one. The first one, look here. Here is the earth and this is the object. Look here. As the height of the object increases, means as it moves away from the surface of the earth, what will be the acceleration due to gravity? Acceleration due to gravity decreases, right? As it approaches the ground, then the acceleration due to gravity increases because there will be more gravitational force of the earth. Followed? Hence we can say that it is, first one is height of the object from the surface of the earth. Height of the object from the surface of the object, earth. Surface of the earth. Just you may remember this one. Height of the object. Then how? Directly or inversely? As height increases, G decreases. As height decreases, G increases. Therefore, they are inversely proportional to each other. I write this as G is inversely proportional to 1 by h. Followed? Okay. Second, dear students, could you tell what is the actual shape of the earth? Do you say that it is exactly spherical? No. The actual shape of the earth is geoid. Geoid means, see, earth, it is bit flatter at the poles but a little bit bulged at the equator, and we call that shape as geoid, like this. It is not exactly sphere. Then look here. What do you call the distance from center of the earth to its surface? That is called radius. Whether it will be having the same radius at all the position? No. Look here. It is changing. So what do you call the imaginary line which divides the earth into two equal parts? That is called an equator. And this is the pole. From equator to pole, as we move from equator to pole, whether the radius decreases or increases? Of course, it decreases. See that from here to the equator more, from here to the pole is less. Got it? Hence, can we say that the acceleration due to gravity depends on the radius of the earth? Yes. As the radius increases, what will be the G? G decreases. As radius decreases, G increases. Okay. You can come to know that in this formula. As the denominator term is more, the whole value will be decreasing. Then as the denominator term will be as it is lesser, then the whole G increases. So we can write another term, radius of the earth. You may call this as capital R or else small r. I take capital R. So how do you write? G is inversely proportional to R. Here I take R1, R2, R3, R4, R5. Okay, and the imaginary line drawn from pole to pole, they are called longitudes, right? And these are the horizontal lines, they are called altitudes or nothing but latitudes. So here radius can also be written as latitude. Followed? Next. Third, assume that the object is on the surface of the earth. See that here. Now acceleration due to gravity will be considered with the distance of the object from the center of the earth. Suppose, imagine that the object is moving inside the earth. Look here. As it moves inside the earth, this much height is decreased. Then this much mass will not be considered. Followed? As the mass of the earth decreases, what will be the acceleration due to gravity? Acceleration due to gravity will also be decreased. Followed? As the object moves deeper into the earth, the acceleration due to gravity will go on decreasing. So we can write it is mass of the earth. Mass of the earth. I take this as M. So G, as mass decreases, acceleration due to gravity also decreases. Hence G is directly proportional to M. Here mass of earth cannot be increased. Just we can decrease. It is only consideration as the position of the object inside the earth. Next, one more. As the depth of the earth, from this only, as the depth of the earth increases, as the depth increases, acceleration due to gravity decreases. Followed? So another one is depth of the earth. Depth of the earth. You may consider the depth as small d. It will be G is inversely proportional to d. As the depth increases, G decreases. As the depth increases, as the depth increases, G decreases. As the depth decreases, the G increases. Okay, these are the four factors. When the object is exactly at the center of the earth, then the value of G will be 0. Then, dear students, can we calculate the acceleration due to gravity on the surface of the earth? Yes, we can calculate. If you want to calculate that, you must know the value of G, capital G. That is, we are already familiar with this. It is 6.67 into 10 raised to the power minus 11 Newton meter square kg to the power minus 2. And M is mass of the earth. That is also known. Even its radius as well. With that information, let us go for calculating the average value of G on the surface of the earth. We know that the value of G changes from position to position, but we are going to calculate average value of G. Okay, please go for writing from there to here. Afterwards, we will move on to calculate. Dear students, now let's go for finding the average value of G. See, this was the question given in the examination. This is calculate the value of G when the object is on or near the surface of the earth. They are not given data. So, because this is very familiar to us, we only should write. Here I'll write data. We are very familiar with the formula to calculate the acceleration due to gravity. That is, G is equal to capital G into capital M by R square. Followed? Okay. See that. Here the object is placed on or near the surface of the earth. When the object is on the surface of the earth, its distance between the object will be radius of the earth. When the object is near the surface of the earth and that distance from the object to the surface of the earth is negligible, hence there also we will consider its radius. Now, first G. What is capital G? It is gravitational constant. So, gravitational constant that is capital G is equal to 6.67 into 10 raised to the power minus 11 Newton meter square kg to the power minus 2. Followed? Then what about capital M? Capital M is mass of the earth. We are familiar with this also. Mass of the earth, capital M, is 6 into 10 raised to the power 24 kg. Followed? Next, radius of the earth. Radius of the earth is denoted by capital R. How much it is? We know its diameter, right? Diameter is 12,800 kilometer and radius is half of that. So 12,800 divided by 2 kilometer, which is equal to 6,400 kilometer. Followed? And it can be written as 6,400 into kilo. Kilo means how much? It is 10 raised to the power 3. Kilo is 1,000. 1,000 can be written as 10 raised to the power 3 meter. Here 6,400 is there. I go for expressing it in scientific notation as 6.4 into, after one digit I put decimal. The remaining 1, 2, 3 are there. Hence 10 raised to the power 3. This is equal to 6.4 into, here bases are same. Even the powers, just go for adding the powers. 10 raised to the power 3 plus 3 is 6 meter. Followed? And we are going to calculate acceleration due to gravity, that is small g. And the acceleration due to gravity is given by, this is the formula. The acceleration due to gravity is given by, can be written as G is equal to capital G into capital M by R square. Now, what is capital G? Let's go for substituting. It is 6.67 into 10 raised to the power minus 11. Here I'll write Newton meter square kg to the power minus 2. Then into M, mass of the earth. It is 6 into 10 raised to the power 24 kg whole divided by R square. R is, what is that? It is 6.4 into 10 raised to the power 6. 4 square is there. Hence I will write again one more time 6.4 into 10 raised to the power 6. And its unit is meter. I will write as it is square, meter square. Then here meter square get cancelled. Which is equal to, here first write all the decimals on one side and exponents on the other side. Here 6.67 into 6 into 10 raised to the power minus 11, then into 10 raised to the power 24 whole divided by, it is 6.4 into 6.4 into 10 raised to the power 6 and 10 raised to the power 6. Here I'll write 6 into 10 raised to the power 6. It is equal to, see that here in the numerator after decimal we have 2 digits. Here 1 digit, 1 digit. So as 2 digits are there in the numerator, we can write in the denominator 2 zeros. In the denominator we have 1 digit, total 2 digits after decimal. I'll take 2 zeros on the numerator. Both get cancelled. We can write 667 into 6 by 64 into 64 into here 10 raised to the power minus 11 plus 24 in the denominator. 10 raised to the power 6 into 10 raised to the power 6, it is 10 raised to the power 12. Now you may go for cancelling. See that 2 3s are 2 3s are 2s are. Understood? Next, let us go for multiplying these. Here 3 7s are 21, 2 is the carry. 3 6 are 18 plus 2, 20, 0, 2 is the carry. 3 6 are again 18 plus 2, 20, 2001 by multiply these two. 32 into 64, 64 twos are, it is 128, 12 is the carry. 64 threes are, 63s are 180, 4 threes are 12, 192, 192 plus 12, it is 204. Followed into here 10 raised to the power minus 11 plus 24. How much it will be? This is 10 raised to the power 13. Next, take this to the numerator. It becomes 10 raised to the power minus 12. I don't have space, I'll write it here. It is equal to 2001 into 10 raised to the power 13 minus 12. It is 1 by 2048 is equal to, now 10 raised to the power 1 is 10. 2001 into 10, it is 20010. 20,010 divided by 2048. Let's go for dividing 20,010 by 2048. See that it will be 20,048 tens are more than 2048 tens are more than 20,000. So that's why I'll go for taking 9s are. 8 9s are 72, 7 is the carry. 9 4s are 36 plus 7, 43. 4 is the carry. 9 zeros are 0, 4. 9 2s are 18. Next. Subtract. So 10 minus 2, it is 8. Here 0 will remain. Then borrow from here, it will be 10. 10 minus 3 is 7. And here 9. 9 minus 4, it is 5. Then 9 minus 8, it is 1. 1578. Then put decimal, take 0. It is 15,780. Then 2048, how much are? It will be approximately equal to, we can take 7 sum, right? 7 8s are 56. 5 is the carry. 7 4s are 28 plus 5. 33. 3 is the carry. This is 3. 7 2s are 14. 10 minus 6 is 4. Then 7 minus 3 is 4. Then 7 minus 3 again 4. This is 1. 1444. Again you may take one more 0. It will be again 7s are. So this is equal to 9.77. Approximately can be written as it is 9.8. But what is the unit? Look at here, Newton, kg to the power minus 2 into kg is there. So on cancelling, here you will get Newton kg. But we all know that F is equal to m into A. Mass is kg, its unit. And acceleration meter per second square. So we can, then how do you go for writing this? It is just we can write meter per second square only. Understood? Yes. So therefore the value of G is 9.8 meter per second square. This is the average value of G on the surface of the earth, but it differs from one place to another place. How? That will be explained now. So once I tell this briefly, listen to me carefully. They have asked you to find out the average value of G. You must know the gravitational constant value, mass of the earth and radius of the earth, and substitute all of them in the formula. Then separate decimal numbers and exponents. Next, remove the decimal. After that, simplify the exponents. Then you go for divide. You will get approximate value 9.8 meter per second square. So please copy from there to here. Hope that you have copied. Just once I tell you the unit. Look here kg to the power minus 1 will remain, and Newton is nothing but kg meter per second square, and this is kg to the power minus 1. These two get cancelled, only meter per second square will remain. Followed? Yes. Now I will go for explaining how the value of G changes as the position of the object changes on the surface of the earth. Dear students, now let us write some more important points about small g, that is acceleration due to gravity. Just we came to know the average value of G on the surface of the earth. Average value of G on the surface of the earth. Surface of the earth. Can you tell how much we got? It is 9.8 meter per second square. And okay, we know that the shape of the earth is geoid. Hence, because it is flattened, little bit flattened at the poles and bulged at the equator. And we also know that the radius changes as we move from equator to the pole. See that this is equator and this is the pole. Okay, the distance of the surface of the earth from the center, it is maximum at the equator, right? As the radius increases, what will be the value of G? G decreases. And this you just compare here. You may take this as R1 and this is R2, and R2 is smaller than R1. R2 is smaller than R1. Therefore, the value of G is maximum at the poles. Followed? So once I write here, the value of G is one maximum at the poles and minimum at the equator. Followed? Next, one more point. What is the value of G at the center of the earth? It is 0. Do remember that. The value of G is 0 at the center of the earth. And another important information is, when you compare the value of G, acceleration due to gravity on the surface of the earth, and the acceleration due to gravity on the surface of the moon, so we can come to know that the value of G on the moon is 1/6 of the value of G on the surface of the earth. Here I'll write. The value of G on the moon is 1/6 the value on the earth. Followed? And another point. Look here. When the object is falling freely towards the ground, then it gains the acceleration due to gravitational force of the earth, and we call that as acceleration due to gravity. Whether the acceleration will be same or different, it will be same, uniform acceleration will be there, and we call that as the positive acceleration. So we can write for free fall body, G is positive. Then when the object is moving away from the surface of the earth, acceleration due to gravity will go on decreasing, hence we take this as, when the object which moves away from the surface of the earth, we call this as projectile body. So for projectile body, the G is negative. That means here plus 9.8 meter per second square and here minus 9.8 meter per second square. So this is the information about G. Next we are moving to another concept. Now you go for copying from there to here. Dear students, today we have got a lot of information about the acceleration due to gravity, and please work out all this today itself without fail. And in tomorrow's class we are going to continue the same chapter. So with this, let us stop the class. Thank you very much.